Hello, everybody. Thank you so much for tuning into the stream today. And I'm really glad that everybody is here today. So, we've been having our entire webinar series around different topics around modernizing legacy systems. And today, we're going to talk a lot more closer to the code level itself. So, today, I want to discuss the different architectural patterns that are followed for developing different systems. So, we are going to be talking about how things used to happen in the past. Why was there an actual need for evolving systems for changing the development practices? And like always, I'm your host, Siddhant. I'm a product executive at Devtron, and I'm also an organizer for the Cloud Native Community Group, Nasik. And with me today, I have Mauricio from Diagrid. Mauricio, would you like to give yourself a quick introduction?
Sure. My name is Mauricio Salatino. I work for a company called Diagrid, and we're working on the CNCF project called Dapper, which is a tool that helps developers and platform engineers to build better platforms. I also wrote the book in 2023. I published it, and it's titled Platform Engineering on Kubernetes, which also led me to a lot of interesting conversations like the ones that we are going to have today. So thank you for having me.
Awesome. And we also have Nishant, who is the CTO at Devtron. Nishant, would you like to give yourself a quick introduction?
Sure. Hi, I'm Nishant, co-founder CTO at Devtron. We at Devtron build developer platform which helps developer to be more efficient in terms of development, deployment, and debugging things. Most of the time, I keep on spend time on Devtron. If I am free, I spend time on reading what next we should be building or figuring out things.
Awesome. So in short, we've got two really amazing folks with us today who've been in the industry for multiple years. So you're definitely going to have some great insights from this entire conversation. If you want to keep up to date with our entire webinar series around modernization and learn about all the different aspects, please feel free to scan this QR code so you can stay up to date as well as get all of the recordings of the previous webinars. So starting off with our very first discussion point, how have the different development architectures evolved over the years? Now, I'm not a developer myself, but I'm aware about a few of the different development patterns. For example, there is the layered architectures, the most popular monolithic and microservice architecture. But these have not existed always, right? Everything has changed since around 2014, 2015, when Kubernetes first became a thing. So before we talk about how the patterns have changed for accommodating Kubernetes, maybe you could discuss a little about what the architecture patterns used to be before the entire emergence of cloud native. Mauricio, maybe you'd like to go first about this.
Sounds good. Sounds good. I'm a developer at heart as well, so I've been building applications for the last 15 years or so. And when I started, I started building web applications, which were architecturally pretty simple. So we can say that at that point, like building layered applications, like in a monolithic structure, was the main thing, where you clearly have a front end or like a user interface. Then you have some sort of like business logic plus access to data, like databases or even like using message brokers. That was quite like the pattern, but all the application was a single thing that you package all together and then you deploy it somewhere, right? After that, I moved to build a lot of Java applications, and in the Java ecosystem, we tend to build, like we used to use like application servers where there were a lot of more modularity in the way that we build our applications, and Java was very close to the service-oriented architecture pattern, right, where you just build services that were kind of like modules that you deploy independently into different application server instances, and then you separated kind of like the UI or the consumers of that business logic that usually was exposed via APIs. To finally jump into Kubernetes, where everything is more like a container that has service that communicates with other containers that can be written in different languages. So in my personal experience, kind of like the evolution was always like you start with a single technology stack, you go to a more mature technology stack that gives you more modularity, to finally go to what you mentioned before, microservices or Kubernetes, that gives you the ultimate flexibility of the technology choices that you use and the architectural patterns that you want to apply. You can still run monolithic applications in Kubernetes, but you will not be using Kubernetes in the best way possible to scale up your applications. So kind of like going through all the phases, and it's super interesting to see people still mixing all these styles today as well.
Love all those points that you mentioned, Mauricio. Like the point about mixing architectures, right? In one of our previous webinars as well, we discussed about mixing all of those different architectures. That was more from an infrastructural perspective. But later in this conversation today, I would really love to see how we're mixing those things in the development aspect as well. So, Nishan, what are your thoughts on how the entire development architectures have evolved over the years?
Yep. So I would agree with Mauricio's the journey which Mauricio described in terms of starting with a single monolith, everything, a very simple application to a complicated microservice mesh, complete microservice we are currently managing and working on. And how this journey started. So let's discuss about this. So what happened? Initially, the only way we knew of building apps was simple: write everything inside a single application, deploy it somewhere. Initial days, there was less scale, so scaling was not a problem at all. At the same time, services were quite simple. Business logic was not that much complex. Earlier, web apps used to be with just simple HTML pages. That's it. From there to a place where behind a web app, even an LLM model can be running. So complexity is huge. So complexity has evolved, scale has evolved. With this, what happened is our SLA started degrading, either due to excessive load, which our server couldn't handle, or business logic complexity, which become hard to manage, or due to which all these requirement our development model, it was very hard to contain in a single application, I would say, or monolith. With this, people experimented with things, and then we realized, okay, we can scale it vertically. To some point of time, this vertical scaling thing was working and solving one part of problem. This was like scaling part. Complexity was still there. At some point of time, somebody realized, okay, what we can do, we can actually extract some logical thing from inside this entire code base and run it separately. Now you have two applications running at the same time. I think this was the magical moment in the software architecture deployment history when somebody realized that I can break entire application into two or three n number of logical part and deploy it, develop it, and manage their life cycle independently. This was the most innovative concept. But with this concept, when we applied this concept, we opened a Pandora box of different challenges and issue altogether. How they should be communicating? What will happen if one failed? How compatible these two micros their version are, different versions are? Uh, there are tons of different challenges we faced. One has different scale, one has both have different scale requirement. So all those challenges we faced, and in this journey, we together as a community of software developer solved all those challenges and reached where we are today. So I think this is how I would like to describe software development deployment pattern architecture journey. What do you think, you?
Yeah. And I think that the big change as well is at least not the big change, but for newer people that it's coming to to the industry at this point, it's kind of like important to describe that companies usually run 20 different applications at the same time, to run their organizations. It's very strange to find a medium-sized company that just runs a single application, right? You usually will have like customer customer repositories and services to do your accounting. So coordination across services is a thing that you will need to sort out sooner or later. And I remember when we were talking about like service-oriented architectures, that we were talking a lot about like system integrations. This was a lot about like how do you integrate multiple system working together. And now in microservices, like the system integration problem, it's there like from day one, right? Like you don't have more applications, you just have like different blocks that you will need to integrate and make sure that the connection between them is reliable, right?
Right.
I love the points that both of you mentioned. Like even with evolution, with how the different architectural patterns have evolved, we've got microservices. The ultimate goal of microservices was to make things a lot smoother, but as Nishant mentioned, it is making things a lot more challenging. How do you take the one monolith and decide which components are worthy of splitting? Even after splitting, it's really difficult to anticipate what are the challenges that might come. Maybe after splitting it, you realize that, oh no, I discarded something which should have been in this microservice. So that I think is one of the real challenges with um, evolving from a monolithic to a microservice-based architecture.
Yeah, there are like mostly for me, at least from my experience, organizational challenges, right? Most of the time, the way that you decide to split the monolith into different blocks is by making sure that you have a team that can be responsible for a group of functionalities, right? So the idea here, there is already that like law that basically says that you should try to organize your software in the same way that your organization works. So if this set of like services or if this department is evolving fast and need to make more changes to the software, they should be able to own that. That should be a decoupled, service that they can update without like waiting for the entire organization to catch up with it. But achieving that is always complex because again, we moved from a monolithic architecture to a service-oriented architecture that required the industry to create a lot of new tooling for building those architectures, and then to microservices. And with Kubernetes, for the last 10 years, we have been building all these tools to enable things to go faster and deal with all those complexities.
Right.
Those are some really great points which you mentioned, Mauricio. So to talk about the next discussion point, I want to talk about all of these different developmental patterns. Maybe we could have a brief touch. We could briefly touch on all of these different patterns: service-oriented, microkernels, micro frontends, event-driven architectures. There's even serverless, which is on the rise today. Like a lot of cloud providers are trying to move towards serverless. So maybe we could touch upon all of those. Let's start with service-oriented. I know you touched upon service-oriented architectures a little bit earlier in the conversation, but maybe we could discuss it a little bit in more depth. What exactly goes on in a service-oriented architecture?
So again, I think that like service-oriented architectures were the previous step from what we have today on fully distributed architectures, right? In service-oriented architectures, we were promoting something similar to what we have now as microservices, but still the technology landscape wasn't there for us to fully implement what was described by that architecture, right? We didn't have Docker, we didn't have something like Kubernetes that will orchestrate all these services. At that point, again, we were dealing with different technology stacks that allow certain degree of modularity, but the execution environments were not as complex for us to fully decouple all the services together. At that point, we used service buses for communicating different services into together in more like an asynchronous fashion, or maybe synchronous fashion as well. And it became quite clear that these service buses became kind of like the single point of failure, because there was like a single integration hub that communicated all the services. And that's kind of like what I think at some point took that idea of service-oriented architectures to evolve to microservices, where every service can talk to each other. We can use different integration patterns to communicate different services. And now we have more robust ways of packaging and deploying our applications, no matter like the programming language that we are using. And with that, you'll kind of like open the door for, again, like event-driven architectures, or even kind of like serverless, not architectures, but like the serverless style of deploying things. I think that's kind of like again, going back to service-oriented architectures at this point might be quite complicated, because again, the technology have evolved quite a lot, where we don't see many of these integration patterns that we saw before. We are just moving away from that. There are still implementations around it, but it's kind of like evolving.
That makes
Yep.
sense. Go ahead, Nishant.
Yep, totally agreed. I mean, ultimately, what service-oriented architecture is, I would say, initial prototype version of what we have today is called as microservices. Implementation of initial prototype version of, but today we have microservices. Things has evolved way more in positive direction from since then.
Mm-hmm.
If I have to look back and implement something in service oriented architecture, I mean, I will be kind of feel handicapped, because
Yeah.
tons of things which we take for granted, tools and technology, which are there already to solve different problem, be it related to how you develop software, to deploy software, to manage their life cycle, how they communicate, how you are monitoring things. Lots of tooling has evolved. They have matured quite a way. So we have advanced a lot, I would say.
Yeah.
Love those points. Before moving forward, there are a few architectural patterns that I would like you to maybe touch upon a little bit. So, based on what I know around the development side of things, we've got things called as a client-server architecture, a peer-to-peer architecture. Now, based on my understanding, this is how things happened before the world of Kubernetes. But I'm pretty sure that these patterns might still be used today. So, Nishant, maybe you could talk about how these patterns were used before and what is their modern day implementation.
Can you just repeat your points?
Sure. I mentioned that we've had peer-to-peer architectures, the client-server architectures. So based on my understanding, these are architectures which were used before the introduction of Kubernetes. So my question is, how have the implementations of these architectures evolved from a pre-Kubernetes era to now in the modern era where everything is based on cloud native and Kubernetes?
See, uh, there are places where P2P communication or client server model were in place. I would say Kubernetes hasn't impacted this deployment models much. What has changed is again library ecosystem, communication pattern, protocols has evolved quite a lot, and which in turn basically they are now default. Uh, their nuances are default for cloud native ecosystem. Rather, I would say that's true, but they have evolved independently. That's a different set of problem statement altogether.
Yeah, I think that I would agree, right? The things that I'm kind of like seeing in the cloud native space now is that, you tend to build more applications that have like bidirectional communications. So there is like a client and a server, but they have like a bidirectional communication open, where before in service-oriented architectures, it was more like, request response or asynchronous messaging. We still use all of those integration patterns and communications and protocols, but I see that tendency where, like, for example, the use of gRPC is quite heavy now when you're building kind of like low latency system that needs to send and receive data like quite intensively. And also like the race of specifications like cloud events or server-side events for, again, building these more dynamic, user experiences and end user experiences and front ends. I think that kind of like makes total sense, because we are evolving the way that we build applications, but at the same time we have users that they require more interactive, front ends that we need to support. So, supporting these new protocols and these new ways of interacting that maybe are extending the old ways. They are implementing the same client server, architecture, but in some sort of like more efficient way, and now it's available for everyone.
Awesome. Love those points. Thanks, Nishant and Mauricio for touching upon all of these different architecture patterns. I'm sure that for folks who may not have been aware of a couple of these architectures might have a good idea about what exactly these architectures are. The next point I want to touch upon is something which we had discussed in the previous webinar as well. So for folks who had not attended the previous one, we had Abdel over and we had this one conversation about microservices and monoliths. So we're all, I'm pretty sure that everyone at this point is aware about what is a monolith and what is a microservice and what's the difference between them. So the or question has always been clear, right? Monolith is just grouping everything together. Microservices are breaking it down together, which makes it easier to scale. Now, one interesting conversation which we had was using both of them together. So for this, Abdel had given a really good example. A couple of years ago, AWS had a monitoring system for Amazon Prime videos, right? So that monitoring system was just for improving the performance of their video playback system. They initially had all of it on microservices, but that was being really high in cost. And just that one particular monitoring service, they moved it on into a monolith model, which improved their cost without impacting performance. In fact, the performance actually increased. So, Mauricio, I wanted to have your opinions on when is it a good idea for having a combination of these two types of patterns, microservices and monoliths?
Yeah. So for me, and speaking generically, because I think that this is something that you need to evaluate depending on your, on your business requirements for the application, and depending on the teams that are working on these. Sometimes you have very, let's say, very end user facing applications that are simple in the sense of like the business logic that they are implementing. And in those cases, I think that separating that into microservices, it's easier than when you have a highly complex application that it's doing something very specific. That it's much more hard to split because you will need experts to understand the different functionalities to split them up. The other point that you touch on is that performance, right? Sometimes it doesn't make much sense to create like a distributed application if you can solve the problem efficiently with a single application, right? And again, it's all depending the kind of like business requirements that you have for the application. So mixing and matching depending your requirements is not a bad thing. Just need to make sure that you understand the trade-offs, right? I've seen a lot of teams that will start by creating a monolith and then start breaking it up. The more that they start hitting issues with performance, for example, or with scalability, right? With the monolith, you cannot scale unless you do it like horizontally, right? You just need to create more copies of the same monolith. With microservices, you might have a set of features that require different scalability parameters. And for those features, it's kind of like the next step is, okay, now you can take it out from the monolith and put it as a microservice that can be scaled independently. But you need to factor in the communication challenges that you will have between these things, right? Sometimes the enabling teams to evolve these services separately pays off for the communication challenges and the integration challenges that you will face by creating a distributed application.
Yep. And I think I would disagree with the one point, with Siddhant, you mentioned that microservices is well understood term today. I don't think.
Yeah, no, it's not.
It's most abused term today.
Yeah.
Uh, what people think, okay, all I have to do is extract out this logic and run a separate application. They will communicate somehow gRPC, HTTP, REST, whatever it is, and we have just built microservices pattern. That's not there actually. Most of the cases, what I have observed, people end up building a distributed monolith,
Mhm.
and
Yeah.
that's the biggest problem. At least we should be understanding what's microservices and take the call accordingly. Uh,
Mhm.
and most of the cases, this is the reason. I mean, I would advise, don't break into macro your application into different different independent application unit unless until you understand what's microservice, what's different monolith, and why you
Yeah.
are extracting that portion of logic into a microservice. But typical problem you are gonna solve with this, and what are different because you are differently gonna solve that problem, one particular problem. But there is no freelance. You will get 10 different problem as a bonus, which you would have to solve. I
Yeah.
mean, how you are gonna solve them? That's also a challenge.
Yeah, I think that's kind of like the advice generally, right? Like if you have a monolith, don't break it because you just want to break it apart. It's just you need to have a very good reason just to break it apart.
Yep.
And
Love those points
when you
which you
start
made.
designing an application from scratch, again, just think about like the business requirement first, besides like what you are going to do like from the architectural point of view. It's like try to understand how end users are going to use your applications. Try to make sure that you have at least an idea of how that would work as a monolith. And then if you are facing scalability issues or if you have a very good reason, split it up.
Right. And what I would suggest while you are implementing this microservices, a very classic literature is 12 factor app. You should try to adopt that pattern. That's that gets ignored in most of the cases, some part of it,
Mhm,
and which defeat the purpose. So that will be, I mean, one advice that I would like to give out to everybody.
mhm,
Please go through and implement 12 factor app.
I love the points that both of you mentioned. So like distributed monoliths, that's something which is quite prevalent. And when I was studying about microservices back when I started my entire journey into cloud native, the one point that almost everybody always emphasized on is that a microservice should run independently, whether the other services are deployed or not. So yeah, the point about distributed microservices, it's quite true, especially when folks are trying to modernize their monoliths into a microservice application, whether that is just for chasing the trends or if it's an actual business requirements, right?
Yeah.
So next, I would really love to discuss about serverless. Has been on the rise. Like folks can save a lot on infrastructure in terms of management, in terms of cost. They don't need to spin up their own Kubernetes clusters or EC2 instances. They've got the compute engine right there, and they just need to write their code, put it onto something like a Lambda function, and they just run it. It listens for the events and takes action on whatever. So, Mauricio, I'm really curious to hear like what are some of the different application design patterns that you've seen which are primarily focused on serverless? And is serverless something which can scale to an enterprise level?
Okay, so those are very, very complex questions. I would say that serverless is like it's already like an architectural style. Um, Serverless offerings are very cloud specific. In this case, you are mentioning Lambda, that's from AWS, and every cloud provider will have their own, framework just to do some sort of like serverless architecture. Um, in my opinion, that's again, it's like with architecture, you can mix and match. But when you go to serverless, you ended up being kind of like constrained by the things that you can do in every function that you create, right? So in order to use a serverless architecture, you kind of like need to buy full into that architectural pattern and then conceptualize all your application functionalities by using the frameworks that, in this case, the cloud provider gives you. Right? For some organizations, that's more than enough. For some other organizations, they want to get the freedom of decide how to build and architect their applications. And in those cases, they tend to go more kind of like with the Kubernetes offering. And this might be because costs, or it might be because of like the knowledge that they already have in their teams. But again, it's up to the organization and to the team and the experts inside the teams to decide which architectural pattern to choose, and then maybe just go serverless or decide something different.
Yeah.
Love those points. Nishant, what do you think about the entire serverless architectural patterns and when would be the best scenario for using them?
Yep. Uh, What I have observed is scenarios where, let's say, you quickly wanted to build something or experiment with something without spending too much time in ensuring that application runs reliably, scales reliably as and when required. For that case, it's a definitely a perfect fit. Uh, but as you scale, uh, that's a constant question you should be asking yourself, and this is true for any design pattern or any architecture, whether this is right thing for our stage, our scale, our side of kind of problem statement. In some cases, based on even team structure, you still would want to stick with some particular technology, although you might have some opinion. So depends on situation. You have to constantly ask the question. But if you have to get started or experiment with something, I mean, serverless you can do reach to a maturity level quite quickly. That's definitely there.
Awesome. Love the points which you've mentioned. So, since serverless is simply abstracting out the entire infrastructure layer, right? The
Mhm.
best use case for it would be to quickly test something, like you mentioned, Nishant.
Yep.
Okay, so moving on to the next principle, or rather the next design pattern. And I think this one is something which is used really widely, especially in a cloud native environment, which is event driven
Mhm.
architectures. Now, event driven architectures, in my head at least, it makes complete sense for when we've distributed the application into tiny services, because something needs to keep listening for the API calls which are constantly being made. So I know that there are a couple of terminologies for this. There is the pub sub model. There are event brokers, message brokers, event queues which are used for this. So
Mhm.
Mauricio, maybe you could start us off with uh, talking about exactly the use cases of an event-driven architecture and how it's useful for the Kubernetes world.
Yeah, so I think that like using like an event-driven approach is it's most of the time the way for us to build applications that are easier to scale and they are like decoupled from each other, right? So the main idea here is that you can have different services that they are not talking to each other, but they are just sending messages that can be consumed and produced by different parties. In that way, again, you enable teams that are responsible for a specific service to design which events they are interested in and then basically react on those events and perform some actions. In this way, it becomes more about like if you want to do something like it's called orchestration, when you said, okay, I will be sending these events in these orders and waiting for these services to process these events to achieve something. Or the other approach is like more like so you have orchestration. The other one is I don't remember the term now, but the other one is more like you just let them pick and decide what to do, and basically they will implement the business requirement that you want to achieve there. So in one, it's more like you are telling the services because you are emitting events in certain order, and in the other one, you are letting the behavior evolves based on the events that you are emitting. And I think that for teams, they really like this approach because, again, they can keep their architecture more decoupled. The service is the only thing that they need to learn about is how to consume and produce events. And that decouple the need for having even services running. You have this pattern enables like you to create architectures where now the service might be down and it can, as soon as it comes back up, it will go to the message broker to pick the messages that are available for it, and then it will just continue processing. So I've seen a lot of teams using event-driven architectures to build like more resilient software that will not break if one of the services goes down.
Right. Uh, I would totally agree with you. One thing I would like to add is when we are building event-driven architecture, the mistakes which I have
Mhm.
seen at multiple places is like our state machine is not well defined or robustly designed,
Mhm.
uh, due to which what happens is we are actually planning We have architecture thing in a so-called event-driven architecture or a synchronous way of achieving something or eventually achieving something. But that doesn't happens because somewhere state is stuck or state machine is broken kind of thing. So one advice I would like to give out is uh, go draw your state machine on a white paper or something, clearly extract out them and reason through them clearly all the possible scenarios. That will help you in architecting robust event driven architecture or application.
Yeah.
Love that, Nishant. So, just for our audiences who may not be aware about what exactly is a state machine, do you think you could give a quick introduction to what exactly you mean by a state machine?
I mean, simple. I think when we talk mathematically, it's like you are at state A or somewhere, what are different possible paths you can take, and
Mhm.
out of those possible paths or states, which are valid, which are invalid, and you have to do this operation across nodes or across event states. This is how you map your state machine completely.
Awesome. So for event-driven architectures, I am slightly aware that there's a different way for making API calls as well. So in the normal monolithic architectures, we use REST, the most common way of making API calls. But now when we move over to event-driven architectures, I'm aware that there's something called as gRPCs, which is a different way of making API calls. Similarly, there's also the pub/sub model. So, Nishant, maybe we could have a quick discussion around all these different methods for making API requests.
Yep. I think at the core of it is event bus. Which technology you have chosen as event bus, that's important. Underlying architecture depends upon that, on that whether you are choosing Kafka for that as event your event bus, or maybe NATS as your event bus, or RabbitMQ or any other technologies, or even some cases I have seen folks using their Postgres as a event store. I mean, everything depends on your architecture should be optimized for your event bus. That's the most important thing. Now coming back to how you can best optimize or leverage these things is uh, understand underlying event bus in detail. They have their behavior, how they behave, what's their architecture is, for what cases they are optimized for, what cases they are not optimized for, and accordingly adapt the pattern.
Awesome.
Yeah.
Awesome.
I
Thanks
think
for shedding light. Go ahead.
no, I was just going to add that yes, like when you build event-driven architectures with a message broker or like Kafka or RabbitMQ or even like the ones that are provided by cloud providers, you can like build the application in a way that again it's resilient because it's not expecting to be called. It's just listening to messages that are coming from different systems. And if for some reason the application fails, the moment that the application gets started again, it can go back and pick more messages from the queue, right? If something fails, the queue will keep that message for whenever the application is back. And that kind of like removes the dependency between services that both of the services needs to be up and running when they are, creating a request between them.
Awesome. That sounds great. Like I knew slightly about how the message brokers work, but the fact that you mentioned like if the receiver service is down, the message broker is just going to keep that in the queue, right, until it's able to
Mhm.
send the message to the correct destination. Like I think that's a really amazing pattern, especially for distributed architectures.
Mhm.
So the final topic which I would like to touch on before we wrap up is about hybrid architecture patterns. Now, for a small scale business, like a startup, for example, they may not necessarily be using hybrid patterns, like using a service oriented architecture along with an event driven architecture or something like that. However, once we shift the conversation to a larger scale, to an enterprise level, it's possible that the enterprise has already multiple different applications which have been running for many years, and they are developing new patterns as well, new applications as well. So what are some of the scenarios which you have seen where these different patterns are used in combination?
I would say that that's the most common thing, right? And again, I'm referring to larger companies, right? Like if you have any large company, you will find something like this diagram, where they are using almost everything because every department made their own definitions. And at the end of the day, you will need to integrate all these tools and architectures together, right? So it is quite common today, even when you work on Kubernetes, to see companies integrating Kubernetes with their legacy services. And that requires a lot of, again, system integration patterns that needs to be applied. That's where, for example, using event-driven architectures to integrate legacy systems makes a lot of sense, because if as soon as you have a way to emit events from the legacy system, you can start building new microservices to react to whatever is happening in there. There has been a lot of new tools for example, in the database space that allows you to extract or create events based on the database transactions. And that allows you to, again, just react from a more modern architecture of what's going on from legacy applications that are storing data into databases. So I think that that's, for me, at least, this is very common. Like it's a very common diagram to see, because every company that I talk to, they would probably have something like this.
Right.
Awesome.
And what I would like to add on is, although this is the situation right now in any big organization, at the same time, this is the biggest challenge for them to simplify this diagram. I mean, I have talked to many engineers or leaders across different organizations, and their main KRA is that how you unify all of them. Even certain patterns like IDP or something like that is towards actually unifying this layer so that a developer experience is same across this architecture or stack, or how we are building or deploying things, managing things, everything remains same, because that's the biggest productivity killer for any business right now. Having this plethora of technologies out there, and trying to make sense, to figure out what should be integrated where, how they communicate with each other. I think this is the biggest problem right now for any organization, mature organization.
Great points that both of you have mentioned. So one thing which you mentioned, Mauricio, that really stood out is the database transaction thing, right? So the previous systems which are still running on older architectures, maybe like service oriented, they are storing information in the database. And for modernizing how that data is used, the database sends it to a different microservice, right? Which is using more modern practices, cloud native, event driven, whatever we can consider. So similar to that, I'm really curious to hear what are some of the different techniques similar to this example about databases that are used for bringing the old to the new.
Yeah, it really depends on the kind of like how old is the old, right? And which protocols these old applications were using to communicate or to store data. Sometimes like there are a lot of frameworks, for example, just to simulate a user clicking through an interface as a way of integrating, right? So sometimes like there are no other ways to integrate besides like creating a script that will go and press some buttons in the screen just to perform an action in an old system. And I basically seen it all. Like there are tons of companies that basically do that kind of automation, and it's totally valid for when you cannot replace like an old system inside the bank because you know that it works, but in some way you just need to keep that up to date with all the latest things that you are building besides that system. It's very difficult to migrate for a large organization from an old legacy system to a completely new architecture, because you need to go through that testing period that sometimes in some cases can take like 5 years. right? So companies tend to integrate a lot to avoid having that cost of, okay, I will just need to build this system from scratch.
Yep.
Awesome. Nishant, would you like to add any thoughts to this?
Uh, I would say IDPs or platform engineering is kind of one step forward in unifying these things, at least at superficial level. Uh, Still, modernizing this core is quite a big challenge right now. I do see, I'm aware of a couple of cloud organizations who are actively working on this thing,
Yeah.
but right now, I would say that's far from being practical.
Awesome. So I guess the only thing we can do is wait and see how things evolve in the next couple of years, and maybe it'll become an actual reality where we're moving to newer technologies from older technologies for organizations of any scale.
Maybe.
Fingers crossed.
Yeah.
Yep.
Okay, so folks, thank you so much for attending the webinar today. Please do feel free to post about this webinar elsewhere and do reach out to us. Let us know what you thought about the webinar. And we will have many more webinars to come in the future. So like I mentioned before, you can scan this QR codes to stay up to date with all of the webinars. So once again, thanks so much, Mauricio and Nishant, for coming onto the webinar and sharing your knowledge with all of our audience. It was really great to have you here and have the amazing conversation with you.
Thank you so much,
Thank,
folks.
thank you.
Awesome.
See you.
Have a good one.